Hi, my name is David Sagastume, and today I'm going to talk about thermodynamical cycles. Hope you enjoy it. So, we'll begin with the definition of thermodynamics. What is thermodynamics? It's the science concerned with the relations between heat and mechanical energy or work. This wonderful science has its own defined cycles, which have become one of the most important tools for the modern human development. Five of the most important thermodynamic cycles are the following. Now let's start to talk about the Carnot cycle. The Carnot cycle is the most efficient heat engine cycle allowed by the physical laws, even though it's theoretical because it's almost impossible to have this cycle done. And this Carnot cycle consists of two isothermal processes, that means that the temperature remains the same, and two adiabatic processes. This means that there is no loss or gain of heat. Now the Carnot cycle begins in the process A, or in the process 1, where the gas expands isothermally, as we talked, without change of temperature, while in contact with a reservoir with a specific initial temperature. Then in the process B to C, the gas expands adiabatically, as we mentioned. There is no exchange of heat, and then in the process C to D, the gas is compressed isothermically again while in contact with a reservoir that has a smaller temperature than it had in the beginning. Now in the process D to A, which it goes back to the beginning, the gas is compressed adiabatically, and the upward arrows on the piston indicate that the weights are being removed during the expansions, and the downward arrows indicate that the weights are being added during the compressions. Now let's talk about the Stirling cycle, known as well as the ideal cycle or the ideal Stirling cycle. And the main idea of this cycle is that a fixed amount of gas is sealed inside an engine, and this involves a series of events that change the pressure of the gas inside the engine, causing it to do work. On the step 1, the heat is added to the gas inside the heated cylinder on the left, and the pressure starts to build. Then this forces the pistons to move down, the piston to move down, and this is where work is done. And the left piston moves up while the right piston moves down, and this pushes the hot gas into the cool cylinder, which quickly cools the gas to the temperature of the cooling source. And this makes it easier to compress the gas in the next part of the cycle, which is the part 3, where the piston in the cool cylinder on the right side starts to compress the gas. Heat generally generated, but this compression is removed by the cooling source. And on the step 4, the right piston moves up while the left piston moves down, and this forces the gas into the heat cylinder where it quickly heats up, and then everything begins again to step 1. Next cycle is the Otto cycle, that is an idealized thermodynamic cycle that describes a typical spark ignition piston engine that is found in every automobile engine nowadays. And the first step is the intake stroke, where the gasoline air mixture goes into the piston through an intake valve, and this piston is sealed and isolated theoretically. And the next step is the compression stroke, and it's where this mixture is compressed at the top of the piston with the volume that is held constant, again theoretically. And the third step is the ignition stroke, where the increased high pressure exerts a greater amount of force, and when the ignition is done by a part of the piston called spark plug, and this ignites the air-filled mixture, and the combustion can occur, and the piston is violently pushed down. And the last step is the exhaust stroke, where the remaining smoke from the ignition is ejected through the exhaust valve, and the cycle begins again. The next thermodynamical cycle is the diesel cycle that is very similar to the Otto cycle. It has as well the four steps. The intake stroke, in this case, instead of diesel, instead of gasoline, it's diesel with air mixture that goes in. And then the compression stroke, where this mixture is compressed at the top of the piston. And the only change with the Otto cycle, with this diesel cycle, is the step 3, where there is no spark plug. There is no spark needed because the compression ignition takes place when the fuel from the high pressure of the fuel injectors constantly ignites. It's alone inside the cylinder without any spark. And this is a synonymous with automatic spark ignition that we are seeing in the Otto cycle. And as well, there is the number 4, which is the exhaust track. Again, the smoke from the ignition is ejected through the exhaust valve. And now, at last but not least, is the dual cycle, which is a thermal cycle that is a combination of the last two we have seen, which are the Otto cycle and the diesel cycle. And this has 5 steps, beginning with the first one, which is the adiabatic compression, where the gas is compressed inside the piston. And the second step is the addition of heat at the constant volume. The third is the addition of heat at the constant pressure. This means that there is a lot of heat added to the volume and a lot of pressure added as well. After this pressure, there is an adiabatic expansion where the work is exerted, and at last the rejection of heat at the constant volume. So that was it, and those were the thermodynamical cycles. I hope you understood it and you enjoyed it. Thank you for watching.